Now we are going to discuss an ammeter. We know an ammeter is an instrument used to measure electric current, right? Electric current in an electric circuit. Since it measures the current in a circuit, so it should be connected in series, or it must be connected in series of the circuit, right? Since we are going to measure the current, so it must be connected in series, right? Due to connection in series, two things may happen. One, the large resistance of the galvanometer will change the electric current, because if the resistance of the galvanometer is large, then it is connected in series, so the effective resistance of the circuit increases and so the current decreases. Second thing is that large amount of current in the circuit, may damage or burn the galvanometer. Let us say this is one portion of a circuit, and in this circuit I current is flowing, and now if we connect the galvanometer in series, you have to connect this galvanometer in series of the circuit. Now we connect the galvanometer in the series. This is the galvanometer, right? Now since the galvanometer has a resistance, and if the resistance is high, then the resistance of the circuit changes, and so current will change. That means we cannot measure the actual current flowing through the circuit. Number one. And number two, if this current is large, then this current also passes through the galvanometer, and that current may damage the galvanometer. Let us say Ig is the maximum current which can pass through the galvanometer. If the current is greater than Ig, then it will damage the galvanometer. And when Ig current is flowing, it shows maximum deflection, that is full scale deflection of the galvanometer. Now let us say this is the galvanometer, right? This is the pointer of the galvanometer. When zero current flows through it, shows pointer is here. Now if the current is maximum, it will produces maximum deflection. Now when we convert this galvanometer into ammeter, then when zero current through the galvanometer, then the pointer of the galvanometer is here, and when Ig current passes through the galvanometer, it shows the maximum deflection, that is full deflection. Ig is the maximum current which can pass through the galvanometer. But if we want to measure I current which is greater than Ig by the galvanometer, then what measure I have to take? What will be the modification? A galvanometer, first thing, a galvanometer must have low resistance, right? Galvanometer must have very low resistance, so that it cannot change significantly the resistance of the circuit, right? If the resistance of the original circuit changes, then the current will change. Then the current shows by the ammeter is not the original current of the circuit, right? Now first thing, the ammeters must have very low resistance. Actually, if the resistance of the galvanometer or ammeter is 0, then it is called the ideal ammeter. Ideal ammeter has 0 resistance, but it is not possible. We can lower the resistance. Now a galvanometer can be converted into an ammeter by connecting a low resistance called shunt parallel to the galvanometer. Let us say this is a galvanometer and we connect a very low resistance which is of S, which is called shunt. Now, if I current flows, if I have to measure maximum I current, then I current flowing through the circuit, and out of I current, just Ig current passes through the galvanometer, and the remaining current I minus Ig passes through the shunt. Right? Remaining current passes through the shunt S, and the PD across the galvanometer and PD across the shunt will be same. PD is potential difference. That is Ig into G will be equal to I minus Ig into S. Or you can say S is equal to Ig into G divided by I minus Ig. That is, to measure maximum I current by this galvanometer of resistance G, you have to connect a small resistance S, which is Ig by I minus Ig into G, in parallel to the galvanometer. And this device is our ammeter. A galvanometer with a shunt. What will be the effective resistance of the ammeter? Effective resistance of the ammeter will be equal to G into S by G plus S. G is the resistance of the galvanometer, S is the shunt we have connected across the galvanometer. Now R effective is Gs by G plus S. Now G is much greater than S. Therefore, we can write this as G plus S is nearly equal to G, and therefore R effective is equal to Gs by G, which is nearly equal to S. That is the resistance of the shunt, and which is very low. So ammeter. So an ammeter is a low resistance device.